Good afternoon. Let's talk about this bonus mark 3 question. So they ask us to do is find the center of mass of a right angle triangle. So this is my approach. So what I did is drew this right angle triangle with a base of B, height of H, X and Y versus X axis. Yep, so we already know X coordinate of center of mass is sum of the area times the X components divided by the sum of total area. So you can write this as that. So it's pretty much as when you integrate X that. So what I've done here is I got a small thin line piece inside this triangle. So from a distance X from the origin, and the height of this is dy because it's such a small height compared to H. So what I'm trying to find is this X center of mass here is the center of mass of this block that's been highlighted. So if you integrate that with dA and you divide that by integration of dA, we can find the X value, X center of mass. Okay, so what we can do, we can find the area of this. We can say the area is equal to dy times this length here. So that length is the base B minus the value X. So dy times B minus X, because of that dA equals dy times B minus X. So we know this line here from origin to straight, it's y versus x function. So we can write it as y equals mx plus c. Since it's going through the origin, we can make it c0. So due to passing through origin, that's why c is 0. So from that we can say y equals, we found the gradient, sorry. So found the gradient m equals h on b, so rise or run. So height h divided by the base b. So we got the gradient of that function, so that we can say the function is y equals h on b x. So from that we can say x equals b on hy. So then what I did is we already found dA equals dy b minus x, dy times b minus x. So what I did is sub in for x. So x equals b on hy. So after that, simplifying it, we got b times dy times 1 minus y on h. So to get the X center of mass here, what I've done is I've add b plus h, b plus x, so b value in x, and divide that by 2. So sub in for x, and I got that there. Then from the initial equation we got the X center of mass equals that. So I'll sub in the values, so integrating from 0 to h, and sub in the values because we're trying to find this X center of mass. So, and sub in what we found previously, simplifying it. So since this half is a constant, that's why it's out. So I just cancelled out the ones I could cancel out. So this is like different of 2 squares, so you can say 1 minus y squared on h squared. So when you integrate that by dy, you get 1 minus y cubed on 3h squared. And the bottom, same thing. When you integrate the bottom, you get 1 minus y squared on 2h. So then you sub in the values. When you sub in the values, you cancelled out the h's. And the 2, and you simplify it further down, you're going to get the x center of mass for right angle triangle is 2/3 of the b value in units. So whatever, so this base value, so x is going to lie 2/3 of b in that line. If you draw a line through that, 2/3 of b, that's where the x point, center of mass, gonna lie, somewhere in that line. So what we got to do to find the exact point, we have to find the y value for the center of mass, and where those two lines intersect, we can say exactly where the center of mass is. Yeah, so I did the same thing for, I'll just do another graph because it's gonna be a bit messy otherwise. So same thing, small piece of area. It's such a small number, so that's why I called it dx. And this height is y. And we know y, center of mass. So y on this. Excuse me. Yeah, y on this value is, so I said the value height is y and the width is dx. So then we can say, so the y center of mass of this shaded area is somewhere around there. So you can say it's this height divided by 2, y on 2. So what I did is sub in the value for y from that function we found. So it's the same graph. Rise over run, we got h on b x, y equals, so we can say x equals b on h y. But we want the value for y, so sub in h on bx. Then we know dA on that, this shaded area, is dx times by y. And sub in for y again, h on bx, get that value, and then you simplify. So this is the actual center of mass, the y coordinate. If you integrate from 0 to b of y of that shaded area by dA, divided by integration of dA, then sub in the values that we already found, and simplify it, and then you get the value for y center of mass of the right angle triangle as 1/3 of h units of the height. So because of that, we can say in a right angle triangle, center of mass lies 2/3 of base, it's from origin, again, and 1/3 of height of the triangle. Yeah, that's it. And yeah, so this is my cardboard piece of triangle I drew. So that's pretty much the 2/3 from the origin, from there to there, 2/3 of that whole length, and that's 1/3. This bit is 1/3 of this length here. So where the two lines intersect is the center of mass, and this is going to be very tricky. So what I did even before joining the string, it's not that accurate, but it's close enough, you could see, because I couldn't find a thin enough string, and I probably would have moved the center of mass a tiny bit when I tried to punch the hole. So yeah, and the parallax errors as well when I'm measuring my measurements. So yeah, and for any other triangle, so we spoke about the question, this is question B. So part B of this, for any triangle, how to find the center of mass. So I just took a pretty basic method. So this triangle ABC, what I did is you find the median of each side. So first median, so median, pretty much if you draw a median from angle B onto AC, that means AC is gonna always divide in half. So if you do that to all three sides, as I said, where the lines intersect in that point, that's the center of mass. That's true for all triangles. So thank you.